Hey, hello everybody. Hey, this is a video on help with worksheet 8.3, which is forces and motion number one, where we're combining forces and motions together. And here are the answers to the first question, the second question, and the fourth question. And what I'm going to do for you is do problem 3 step by step, and the other ones will be similar, but slightly different. Okay, so in problem number 3, it says a 17 kilogram boulder is accelerated from rest to 4 meters per second. So, and right here, we've got a final velocity of 4 meters per second before it falls off. So now, after it fall off, it would accelerate due to gravity. But this question is only talking about this little middle part here. It says, how much force did it take to make the boulder accelerate? Okay. Now, if you guys think about it, we're going to have some sort of applied force, okay? And we're obviously going to have some frictional force, but overall, this that applied force has to overcome all of the frictional force. So really, we're really talking about the net force. So the applied force is actually going to be greater, and then we subtract it out. So we're really, in this question, we're really just worried about the net force, and so we don't have to worry about the friction like we have in some of the other problems. So now we're just going to list out some of the things that we already know. So we know the mass is 17 kilograms. We know the initial velocity is 0. We know the final velocity is 4 meters per second. We know the distance is 8 meters. And now we need to kind of figure out everything else. And I would like you to realize, so remember these are those 4 equations that I have given you before in kind of the order that I've given it to you. And we're going to use those equations to figure out a lot of what we have in problem number 3. Okay, so so in the first equation over there, we're going to have average velocity is equal to the final velocity plus the initial velocity divided by 2. And we know the final velocity is 4, and we know the initial velocity is 2. We divide by 2, and we get the average velocity of 2 meters per second. So 2 meters per second is our average. So we're also going to say the velocity average is going to equal to distance divided by time. But we're going to flip these two because we want to get time all by itself. Okay, so time is going to equal to displacement divided by velocity average. So we're going to have 8 meters divided by 2 meters per second squared. And we can do the math there. 8 divided by 2 is going to be 4 seconds. Okay. We also know that the change in velocity is going to be 4 minus 0, which is 4 meters per second. And now I can actually use equation number 2 in a slightly different form and say acceleration is equal to v final minus v initial over time, which is going to be 4 minus 0 divided by 4, which is going to give me an acceleration of 1 meter per second squared. 1 meter per second squared. And now I can calculate the net force. The net force is equal to MA. So I can have 17 kilograms times 1 meter per second squared. And that's going to give me 17 newtons. 17 newtons. All right, so you guys, a big part of this worksheet is for you to combine the concepts of force and friction and all the kinematic equations, average velocity, final velocity, acceleration, displacement, time, all those sorts of things, and you got to put them together. So this can be a really tricky, but you kind of have to sort it out and put all the pieces together. So you might end up going down the wrong road and you might need to kind of start over. Okay, so a lot of this is just persistence. So good luck with that. And I will help you on the flip side. So hope this helps. Talk to you soon.